Lesson 28, Multi-Dimensional Arrays. To follow along with this lesson, you will need to create a new console project and add a new file named main.cpp to it, as we did in Lesson 1. We covered one-dimensional arrays like this previously. Some data, however, is better represented with a multi-dimensional array. For example, this array of characters might represent the exam grades of 5 students on a particular exam. This works well if there's only one exam. However, if we have 3 exams, it is more convenient to use a two-dimensional array like this one. Here we show the code to declare and initialize that two-dimensional array. For the initialization, we put the values into nested braces. We use 2 sets of square brackets to declare the array and access its elements. Running this program prints out the elements of the array in the two-dimensional form, since we put an endline at the end of each grade loop. When we declare a two-dimensional array like this, it is put into memory, which is one-dimensional, so the second dimension is actually stored sequentially like this. The arrows show where the first index increments at every 5th element. The compiler understands that the index inside the first bracket offsets the location by multiples of 5, but the second index only offsets the location by 1, so we can actually index the element at 2, 1 as 1, 6 or 0, 11. We can even access it as -1, 16. Executing this program, we see that all these array accesses get the element at 2, 1. Although this is possible, I am only doing it to illustrate the memory layout. In practice, I would recommend keeping the indices in the bounds 0 to 2 and 0 to 4 as a general rule. Looking at our first program again, we remark that we do not actually need to put the 3 in the first bracket. This is perfectly acceptable. The 5 is needed, however, since it tells the compiler that the offset for the first index is 5, as we just saw. We can put our printing code in a separate function and pass in the array to print it. Note that in our function signature we did not specify the first dimension size again. For arrays, the first dimension size is always optional. However, we do need to specify the rest of the sizes since they are used to determine the offset of earlier indices. Now suppose these students took 2 semesters of courses with 3 exams per course. We can specify that relationship with a 3-dimensional array like this. Again, we do not need to specify the size of the first dimension. In this example, we have added another loop to our printing. Executing the program, we get the grades for both semesters. We can clean this code up with some enumerations. Here we declare enumeration types for the courses, exams, and students. Notice that the last entry in each enumeration is called count. If you recall how enumerations work, then you realize that this last entry is equal to the number of values in each enumeration. So these count values may be used to declare our array of grades like this. Using these enumerations, we can refer to the grades conveniently by using the enumeration value names. For example, to access Betty's midterm exam grade for data structures, we can simply write this. Finally, it should be said that arrays do not need to be initialized when they are declared. However, you should initialize the entries at some point before you access them, because they are usually filled with strange values like this. Here we have added code to initialize all of the entries to 0 before we print the array. You'll often find yourself writing code to do this. This concludes the lesson.